The last section in Chapter 6 gives us another law to solve oblique triangles, so non-right triangles, which we'll use in some real-world applications. It also leads us, we'll kind of finish the chapter talking about how to find the area of any triangle, not just the right triangles that we have, the half base times height formula, but any triangles, oblique triangles. These two formulas kind of lead to these, giving us ways to find areas of any triangle that we want to find. Alright, the title of this section was Law of Cosines. Here is the Law of Cosines. If we have, again, any triangle ABC with sides A, B, and C, respectively, Law of Cosines is this. It says that A squared, that's little a for the side, is equal to B squared plus C squared minus 2bc cosine of A. Okay. Notice, let me highlight those pieces here. In order to find side A, you need side B, side C, and angle A, the angle between them. Essentially, you can rewrite this formula three different ways. You could write it for B squared, you could write it here for C squared, but essentially it always works out the same. Any side squared is equal to the other two sides, the sum of the squares of the other two sides, minus twice the other two sides cosine of the angle between those two sides. Okay? There is an alternative form that is solved for the angle instead. It says that angle A is equal to cosine inverse B squared plus C squared minus A squared over 2BC. Okay, so there might be instances where you're trying to find not a side in a triangle, but quite possibly an angle of a triangle, and if that's what you're after, then law of cosines can be rewritten. Okay, all I did was this. I just kind of moved these two terms opposite sides, so that would have said b squared plus c squared minus a squared, and divided by the 2bc, and did the cosine inverse, getting the a all by itself. All right, let's do a couple of problems utilizing these law of cosines. First example that we're going to look at is the example of a side case. So we know all three sides of the triangle. In a situation like this, we need to find an angle first, and you always want to find, say, the biggest angle first. Okay. So we're going to use that alternative form of law of cosines. We're going to be looking for angle A first because it's across from the longest side, therefore it's the biggest angle. Okay, and law of cosines says this. It says that angle A equal to cosine inverse. I start with the other two sides first. Okay, order doesn't matter. I take away the side across from the angle I'm looking for, divided by 2 times 5 times 7. Okay, so this is angle A equals cosine inverse of whatever that is. Let's compute that. 5 squared plus 7 squared minus 9 squared divided by 2 times 5 times 7. This is negative 0.1. And I now want cosine inverse of that answer. So A is 95.7 degrees. Okay. Once we get one of the angles found, now we revert kind of to easier techniques. I'm going to now try and find another angle, but I'm going to use law of sines to do it. I'm going to say that the sine of 95.7 degrees over its opposite side, 9, is equal to, and we can pick any angle, it doesn't matter, maybe the sine of B over 7. So the sine of angle B is going to be 7 sine 95.7 over 9. We're going to do sine inverse of whatever that is. And so on the calculator, here we go. I get B to be 50.7 degrees. Okay. Now, to finish this problem, it gets even easier, if you can believe that. To find angle C, since we know 2, we just do 180 minus the other angles. This is 33.6 degrees. And we're done. In this next example, we've got a side angle side case. So we've got two sides, and notice the angle here is between the two sides. This 20-degree angle is right there. Okay, so in this situation, when you have a side angle side, you're going to begin by finding the opposite side. Okay, the formula says c squared. Okay, I know the formula 2 slides ago said a squared, but again, we can rewrite it for anything we want. The way it works is this. I don't memorize the formula. I just memorize kind of how it works, like how to plug in the numbers, and it works this way. I take the square of the other two sides, add it together, minus 2 times the sides times the cosine of the angle between them. Okay, so that comes out to be, let's plug it in and see. That comes out to be 42.63, but that's the square of side C, so we need to take the square root of that answer, and we get side C to be it's going to use 1 decimal point, 6.5. Okay. Well, at this point we now need to find one of the angles, but notice now I have this C pairing, so we can now use law of sines. Say sine of 20 degrees over 6.5 is equal to, I'm just going to go with angle B over the side across from angle B. So that's going to be sine angle B equals 5 sine 20 over 6.5. I'm going to do sine inverse of that. And angle B is 15.3 degrees. And then to find the last angle, angle A, it's just 180 minus 20 minus 15.3. And so angle A is 144.7 degrees. We've got them all. And how about a couple of application problems? First one says that, let's see, it's a survey problem. We've got, Tony must find the distance from point A to point B on the opposite side of a lake. So he locates another point C that is 860 feet from A and 175 feet from B. He's able to measure this angle between these 2 points to be 78 degrees. And he wants to know what's this distance over here, which would be like a little c across from angle C. Okay, so we've got a side angle side, which is a classic law of sines case. c squared is going to be, I need the other two sides squared, minus 2 times the sides, times the cosine of the angle. I gather that's going to be a fairly big number. And it is 707,643.5811. We want the square root of that number. I get 841.22 feet. That's it. Okay, a football problem. It says a player waiting to receive a kickoff stands at the 5-yard line, point A. Okay. As the ball is being kicked 65 yards up the field from the opponent's 30-yard line, the kicked ball travels 73 yards at an angle of 8 degrees to the right of the receiver, as shown in the figure. Find the distance the receiver runs to catch the ball. So we are interested in finding this distance from A to B. So we don't know that distance, just call it whatever you want. Maybe you call it x. So Law of Cosines says that x squared is equal to the other sides squared and minus 2 times the sides times the cosine of the angle between the sides. So we're to the calculator again. And I'm just typing it all in one big long line. I'm not trying to break this up into steps at all. Okay, there's that. I want the square root of that number, and I get x is 12.5 units are yards. That's how far he had to run to catch the ball.